So as our first exposure to computer science, we should have gone over how to think like a computer scientist, and you kind of a basics of how programs or computer programs function. And now what I want you to do is to come to this same platform, Runestone Academy. You do not need to make an account. And what we want to do is problem solving with data algorithms and data structures. And so if you click on that, then it'll take you here. And this is basically what a, what is it? Yeah, second, like if you did study computer science, it would start with the intro, which is essentially the topics that were gone over here in how to think like a computer scientist. Maybe not all of them, but about half of those. And then the second class that you would take would be part 2, which would be this, the second half of how to think like a computer scientist. And then the third class you would take would be algorithms and data structures. And so that's kind of what we want to use as our foundational material. And so if you come through here, what I want you to do is, we can go ahead and skip the introduction, but if you have the time and the motivation, go ahead and read that. It can only help. Right here with analysis, there's one big idea here that definitely you want to understand, and that's big O notation. And that's simply a I guess a way that computer scientists can rate how fast or slow a algorithm is, right? And so you definitely want to wrap your head around that. It's not that big of a concept, so I think you guys should be able to kind of read through that and get an idea of what is meant by a logarithmic algorithm, a linear algorithm, log linear, and then quadratic. This is like what, n squared, and then this is n to the fourth, and this is like n to the x, which is exponential. So like this is like the worst possible type of algorithm because it takes so long. And then a logarithmic algorithm is very fast. And so what Dr. Umans was talking about during his introductory lecture in the College and Career Center was how to get, I guess, what was it? It was how to minimize the worst time case, or the big O of matrix multiplication. And so like there were like small tricks, like typically it's quadratic, it's like what, x to n squared, and people were able to, I guess like use little mathematical tricks to gnaw away at that and get n to the 1.99 and then n to the 1.7, right? And so the holy grail of matrix multiplication would be to get a faster, one that's not quadratic but maybe log linear would be a huge step forward in that area. And so yeah, you definitely want to get your head around big O notation, so let's do that all together. And then what I want to do is assign each of you a certain topic. And so the 3 topics that I'm going to choose, that means there's going to be groups of 2, so you're going to pair up, would be, let's skip recursion, it's not really necessary, would be sorting and searching, that'd be 1. And then another would be trees and tree algorithms, and then the last one would be graphs and graph algorithms. And so sorting, I think it's more of a easier kind of a topic. So those who are new to Python, you might want to gravitate towards sorting and searching. And the trees and tree algorithms get a little bit more sticky, so these involve recursion, which is a topic that I had you skip. So I would suggest that only those who are comfortable with recursion go ahead and tackle this this topic here. And then we have graphs and graph algorithms, which is also a a more sticky topic to jump into. So maybe somebody or a group with a little bit more experience, or maybe I would say the motivation to tackle this problem here, right? Because there's going to be quite a bit of homework that you need to do in order to wrap your head around these different types of algorithms, like Dijkstra's algorithm. And so yeah, this is what I want you to study, and at the end of it I want you to each put together a entry into the concept map. And so if it's a group of 2 and you are studying tree and tree algorithms, then your concept map for one person in the group might be binary search trees, and then for another person in the group it might be search tree analysis, right? And so what I want is every student to have one entry in their concept map at the end of this week. And yeah, I guess the grouping can be done organically, and also the choosing of the 3 different topics can also be done organically. So good luck with that.